right, ladies and gentlemen, we're starting to talk about section 5.3, and the big thing today is about rational numbers, which means we're talking mostly about fractions, okay? So what I want you to write down right now is the definition of a rational number, which is a number that can be expressed as a quotient of integers, okay? Some examples of that are 1 over 2, negative 3/4, 5, and negative 6. Now, listen, even though 5 and negative 6 are whole numbers, they can still be expressed as a fraction, because 5 divided by 1 is 5. So those are still considered rational numbers.
What is n? Is that natural?
Oh, yes. So before we've talked about real numbers, and this is like the special symbolic form of what real is. It's like this double lined R. This is a real number. Z, I don't know where they got Z for integer, but that's what Z is integers. Q is a rational number. Q for quotient is how I remember that. N for natural. Okay? Okay, some non-examples of a rational number. Anything divided by 0 is undefined. Okay, so you can't have a rational number divided by 0. Pi and square root of 2 are considered irrational. They have a crazy decimal that goes on forever. Okay, it has no rhyme or reason or pattern to it. It's just what it is. And then you have the imaginary numbers that are not rational. All right, so as you guys recall, a fraction is in the form of a over b, where a is the numerator and b is the denominator. Okay? So whenever you see something that says reduce to the lowest terms, if I take the number 130 over 455, I think probably most of you already know, because it's got a 0 and a 5 in it, you could divide them both by 5 and keep reducing. But this is another way that I've learned to do it, and I think sometimes it's easier, is to go ahead and put it into its prime factorization. So you know that 130 is divisible by 13 and 10, and then 2 and 5. So I can write it like 2 times 5 times 13. And then 455 is divisible by 5 and 91, and then 7 and 13. And then I can write it over here as 5 times 7 times 13. And the nice thing about that is I can just cancel out the repeats. So 5 and 5, 13 and 13, and that leaves me with 2 7s. You guys, we have a mixed number and improper. Going from a mixed number, mixed numbers are written in the form of A, B over C. And then improper fractions are written in the form B over C, where B is larger than C. So in other words, an improper fraction is kind of top heavy. Okay, so remember the top one is bigger than the bottom. The numerator is bigger than the denominator. So if I wanted to convert a mixed fraction to an improper, this is what I'm going to do. I'm going to take 5 times 3 plus 4 over 5. So basically I'm taking these two and multiplying them and then adding the 4 to it. So that would be 15 plus 4 over 5, which equals 19 over 5. All right, so we want to convert from an improper fraction to a mixed fraction. So what we're going to do is actually do a little long division. Okay? We're going to take the top number and actually write it as like this and put it in the fraction bar, or not the fraction, division bar, and divide it by 5. So 5 goes into 42 how many times? 8. So it'll be 8 times 5 is 40, and I have a remainder of 2. One thing you need to know is we're going to look at this clockwise. So I'm going to start with the number 8, go through the number 2, and end with 5. So this will be 8, 2 over 5. Okay? You always look at it clockwise. You're going to do the same thing with 711 divided by 20. So 20 goes into 71 3 times. 3 times 20 is 60. If we subtract 60 from 71, we get 11, and then we're going to bring down that 1. So it'll be 111. 20 goes into 111 5 times. So this will be 100. And if I subtract that, I have 11 as a remainder. So once again, if we do this in clockwise order, starting with the 35, we go through the 11 and up to 20, it'll be 35 and 11 over 20. Okay, so next we want to talk about how do you express a fraction as a decimal. Okay, so we want to look at, see what 5 is divided by 8 in decimal form. Okay, 8 obviously does not go into 5. So what we're going to want to do is add a decimal to it and add a 0. So I'm going to put that right here. So because the decimal is here, right directly above it, I'm going to put my decimal right here. So 8 goes into 50. How many times? 8 times 8 is 64, so that's too big. 6, yep. 6 times 8 is 48. And I'm going to subtract 48 from 50. What do I have for 2? Okay, now here's a problem. We're not done yet. So we're going to add another 0 to it. Right here. And I'm going to bring that 0 down to this. Okay, 8 goes into 20. How many times? Twice. So 2 times 8, 16. Subtract that. We have 4. Not done yet. Add another 0. Here we go. Bring it down. Eight goes into 40. How many times? 5. So 40 minus 40 is 0. We're done. Okay? So the answer in this is 0.625. So that's the same as 5/8 in decimal form. Until you terminate. Yep. Yep. Let's do another one. 7 divided by 11. So we're going to start off with 7 here and have 11 on the outside. Well, obviously 11 does not go into 7. So first we're going to add a decimal and a 0. Okay? 11 goes into 70. How many times? 6. And there's going to be a decimal point right here. So 66. 70 minus 66. 4. Got to add another 0. Okay. So 11 goes into 40. 3 times. 3 times 11 is 33. We have 7. Add another 0.
6.
Yep. So we got to do this again. 6 times 11.
Isn't it just 636 repeating?
Yes, exactly. It's 636 repeating. We now see that. So we're going to write this like this. 0.63 repeating. We could do this until the end of age, until the cows come home. So it's just 6.63 repeating.
What did you put 6.63?
We're going to go back from decimal to fraction. Look at this 0.7. What place is that? Tenths. So we're going to actually just do 7 over 10, and that's it, right? That one's not hard, yeah. How about this one? What place is that one in? Hundredths. So I'm going to say 49 over 100. Can I reduce that?
This is too hard.
No. Okay, this is in what place right here? Thousandths. So I'll be 48 over 1,000. Okay, can I reduce that? By golly, yes I can. Okay, so this will be 24 over 500. Can I reduce that again? By golly, yes I can. And then that'll be 6 over 125. All right, so now we're going to do a repeating decimal here. We're looking at the decimal number 0.6 repeating. Okay, so here's the first step. You're going to want to let n equal the repeating decimal. So n is equal to 0.6666 ...
Devil.
4 sixes, not 3.
Yeah, I know, I'm just saying that.
Okay? So that's the first step. The second step is, because there's only one repeating decimal on this, we're going to just take it times 10. But if there were 2 repeating decimals, like 0.636363, we're going to multiply it by 10 times the second, which is 100. If there were 3 repeating decimals, it would be times 1,000. Okay?
What's after
10,000. Yep. Okay, so this one's going to be times times 10, so 10 times n is 10n. And then 10 times 0.6666 ... is the same thing as 10n equals 6.666 ... We're going to take the second equation minus the first equation. So that's going to be 10n equals 6.666 ... minus n equals 0.6666 ... We're subtracting them. What that does is that gets rid of that repeating 6. Yep, so it'll be 9n equals 6. Okay? Then we would take that equation and actually solve for n. We're going to divide both sides by 9. So n is 6 divided by 9, and if I reduce that, that'll be 2/3. So the number 2/3 is the same thing as saying 0.6666 repeating. Okay, so now we're going to do the same thing with a repeating decimal of 0.53. This has 2 digits in it. Okay? So I'm going to express this as n equals 0.5353 repeating ... Okay? And then because there's 2 digits in this, we are going to multiply by 10 to the second, or 100. Okay, so this will be 100 times n equals 100 times 0.5353 ... Okay? So we have 100n equals 53.53 repeating. And then we're going to actually do some, take the second equation and subtract the first equation. So we have 100n equals 53.53 repeating minus n equals 0.53 repeating. When we do that, we have 99n equals 53. Because the 0.53 repeating gets canceled out. So 99n equals 53. So the equation is, or the fraction on this is not 53 divided by 99.